All right. Okay. So on Friday we talked about tidy data and tidyr to get your table or your data into tidy form. And today we're going to talk about data wrangling with dplyr. And I guess everything here is kind of assuming your data is already in tidy form. And this is it, dplyr. So dplyr is one of the core libraries in the tidyverse, all right? And you can load it up with library dplyr or library tidyverse. Tidyverse will load up dplyr as part of it. And we use dplyr for data manipulation, things like summarizing it and arranging it and doing stuff. Handling our data is done very efficiently. It can be done very efficiently with dplyr. There are certain towards the end we'll look at group by and summarize, and it's very similar to tapply, but my personal preference is using dplyr. And I think you guys all learned tapply, right? Tapply and stats 20 and things like that. Again, my opinion, I'm a big fan of the tidyverse, and so I teach these functions and packages. And so what dplyr will offer is these are kind of the 5 primary verbs that you can master in dplyr. And once dplyr offers a whole bunch of other functions and quote verbs that you can use, but I would say these are the 5 primary ones. We've got select, and that's going to select columns or variables. Filters rows. Okay, so the different cases and observations get filtered. We can create new variables using mutate, right? The results we can sort using arrange, and then we can summarize. And summarize will take the different observations and produce summary values. And all of these things can be combined with a group by, which is a very powerful thing that allows us to do summaries for different groups within our data. Okay. Here's a cheat sheet that you can download and print out. Okay. And if you click the cheat sheet, okay, you'll see that there's a whole bunch more verbs that I don't really get into. Okay, so at the top you've got filter, but then there's other ones like distinct and sample, and then we'll look at arrange, but you can do more stuff. Okay, and then we'll look at mutate, but there's a whole bunch of other things, transmutate, mutate all, and stuff like that. Okay, and then there's all sorts of stuff that you can apply here. Okay. So download the cheat sheet and work through that. A lot of the examples that we're going to look at today is going to use this data set, the Star Wars data set. I don't know, do we have Star Wars fans in here? Okay, all right, a few of you. I see you guys. All right. So Star Wars is the story of basically the Skywalker family, and we're first introduced to Luke, and so this is a table with I think there's 87 characters that exist in this table, and they've gathered information such as stuff that you don't really know or maybe even care about, but how tall is Luke and how much does he weigh? His height and his mass, hair color, skin color, eye color, birth year. Birth year is, in the Star Wars universe, is measured as years before the Battle of Yavin or after the Battle of Yavin, which is, it's not important, but the climax of the first original Star Wars movie, Episode 4, was the Battle of Yavin, where the Death Star, whatever, gets destroyed. Okay, so anyway, I'm not sure. I don't know how a year is measured in Star Wars universe, because it's not like they're revolving around the sun. But anyway, Luke is 19, so apparently. So that's what we've got, and we're going to look at this. And again, because it's a tibble, the columns that don't fit get described down here. We've got species, films, vehicles, starships, and things like that. All right, and so the first verb we're going to use is select. Select, the way it works is you say select, you give it the name of the data frame that you're working with or tibble that you're working with, and then you list off the names of the variables you want to select. So in this case, I'm going to say select the name and then their homeworld, the species, and films. And we've got Luke Skywalker from Tatooine, who's a human. And then apparently he's in, this has data from the first 7 movies, okay? And so, he makes an appearance in 5 of those films. Maybe that's a spoiler. But so that's what we have here, okay? You don't need to put quotes around the column names if they're one word, okay? If they're more, if there's like a space in the name or if it starts with a number or something, which is not good practice, then you can use like backticks and stuff. And that's that, okay? Throughout the rest of this lecture, and what I also recommend when you use dplyr is you make use of the pipe function, okay? And the pipe function is this. It's this % greater than %, and we call it the pipe. And basically what it does is it takes what comes before the pipe. In this case, it is the data frame or tibble Star Wars, and it takes that and it puts it in as the first argument of the function that follows, okay? So on this slide, I had select Star Wars name, homeworld, species, films, and doing Star Wars pipe select is exactly the same as this up here, where we do select Star Wars, okay? So whatever comes before the pipe gets inserted as the first argument in the following function, okay? And this allows you to kind of chain operations, because the result, when you use dplyr, basically everything you do will result in a tibble, okay? And so the result of this, I haven't stored it anywhere, is a tibble with 87 rows and 4 columns. And then I can take this 87 by 4 tibble, and I might want to do operations to it, okay? And so, an old-fashioned way would be like I take the result and I store this somewhere, okay? And then I take that storage and then I would apply another function like filter the name of that new data frame, and then, whatever I do. But in this case, I can just kind of chain operations using the pipe, and I'll demonstrate that very shortly here, okay? But here we're focusing on select, okay? Talking about the verb select, and we use this to select columns, okay? A shortcut for inserting the pipe, because it's a little annoying to type % greater than %, is you hit Control-Shift-M or Command-Shift-M on your keyboard, and that will insert pipes into wherever you're writing, okay? Control-Shift-M, Command-Shift-M. All right, when you're using select, there's some nice features. You can use the negative sign to not select those columns. So we say I don't want name, eye color, and birth year, and it selects all of the other variables, okay? And then here you can see what I've done is I've taken the result of select and I've piped it into the function head, and I say I just want the first row, okay? So select here, this is going to be an 87 by 10, right? So when you do select, there's 87 rows, and so it's going to return all 87 rows, 87 by 10, and then here I pipe it into head, and so it just gives me the first row, okay? 1 by 10. You can use colon notation to select a range of columns. So here I want to select the columns name through eye color, okay? And that's going to get name, height, mass, hair color, skin color, eye color, okay? And again, these are in the order that they appear in the original data frame, right? So so name, height, mass, hair color, skin color, eye color, birth year, gender, homeworld. We just said we want everything from name through eye color, and that's exactly what it gives me. So colon notation saves a lot of time. Dplyr also comes with a bunch of select helpers. These are helper functions that makes selecting, if you've got a big data set with a ton of different variables, these select helpers can be useful, okay? And you can always ask for more help checking the help on tidy select helpers, okay? So there is contains, and so it's going to select columns that contain a certain character string, or you can say starts with or ends with a certain word. There's matches, and we'll cover regular expressions on Wednesday, but this allows you to select column names based on a regular expression, right? So, depending on your data set, right? If you only have like 12 columns in your data set, not a big deal. But sometimes you might have a data set where there's like 50 columns, okay? Or maybe even 500 columns, who knows, okay? And you might want to select the columns based on a regular expression, which we'll look at. Okay, everything will select all the columns, numeric range. Sometimes you get variables named x1, x2, x3, x4, or v1, v2, v3, v4. So look up the help on numbered range, and you can select columns that fit that kind of format. And then sometimes when you're dealing in a function or a loop or something, you might have a vector where you are storing the names of columns, right? So you might have some name vector where you've got the names of columns, and then you can use one of, and then you put in that vector name, okay, that vector of names, and it will select all the columns that exist in that name vector, right? So that's a useful function there. All right, so just a couple examples of this. I did Star Wars, and then we're going to select the columns. Select is for columns. Select the columns that ends with color, okay? And so this selects the columns hair color, skin color, and eye color, okay? I know we haven't covered regular expressions yet. We'll do this on Wednesday, but this one, $$ basically means the text ends with an S, okay? So I guess it's the same as doing ends with, but here you can put in any regular expression here. And so here we're going to select columns that end with the letter S. So that's going to be mass, species, films, vehicles, and starships. Okay, so on and so forth. We have the function filter. Okay, filter will select rows. We filter down the rows or the cases down to the ones that we match. Filter is going to work anytime you've got a logical vector. Okay, with a length equal to the number of rows. So in our original data set, we have 87, okay? And if you have a length 87 logical vector, you can apply that, throw that into filter, and it's going to select certain rows. So here, basically, my logical vector is name equals R2D2, right? And so this is going to be false for pretty much everybody, except R2D2 will be the only one that's true, and so this selects the one, filters down to the one row where the name is equal to R2D2, right? And then we can see R2D2 has a mass of 32, has no hair. The skin color, I guess, is white, and this is blue. Eye color is red, if that's what we call R2D2's eye, okay? And again, birth year, I guess he was 33 Star Wars years old at the Battle of Yavin. Okay, so this is what we've got. Filter rows with filter. Okay, here's another example. Okay, you can give it multiple conditions. Using a comma is equivalent to using the and sign. All right, and so here one thing I'm using is species %in%. Okay, %in% is a convenient way to see if a character string is one of certain things. So we're going to just say the species is either human or droid. Okay, and so so we look at humans and droids there, and then we say and the height has to be less than 175. Okay, and so we see these are characters who are humans or droids with a height less than 175. You can combine filter with regular expressions, okay? So again, we'll learn regular expressions on Wednesday. but you can use this function string detect. String detect will return basically a logical value if it matches or if it detects this string inside the it detects this pattern inside the string. So here caret F means the string has to start with a capital F, okay? And so here we have filtered down to the rows that where the name starts with a capital F, okay? And so we have Finn from the new trilogy, and then this is, we looked this up earlier. Finis Valorum from the Phantom Menace. But I don't, Phantom Menace is probably one of my least favorites, so I don't really watch it too much. Okay. And again, you can take the results. So the result of each of these things is a tibble, which means you can then pipe it into the next thing, right? So Star Wars gets piped into filter, and we're going to filter this entire Star Wars data set so that either they have no hair color, okay, hair color is none, or eye color is black, right? And so we can use the OR operator. And so here we do that. And then from there, we pipe it into select, and we're only going to select these five variables: name, species, homeworld, hair color, and eye color. Okay, and so we see Darth Vader gets selected because his hair color is none. Okay, apparently Darth Vader's eye color is yellow. I'm not sure if I agree with that, but that's what we've got. Okay, and then Greedo gets selected, okay, because Greedo's hair color is black. So even though his hair color is an NA, which is not equal to none, he gets selected, okay? And we get all of these people who don't necessarily have black eyes, but they get selected because their hair color is equal to none. All right, so that's, again, kind of a combination of filter and select there. We can create new variables. New variables use this function called mutate. Okay, and when you do that, the way it works is you take kind of whatever tibble you're working with, and then you pipe it into mutate, and then you just define the new variable that you want to create. So in this case, we're going to create a new variable called height in inches, and we're going to take the variable height and divide by the number 2.54. Okay, so height is currently listed in centimeters. We divide by 2.54, and it's going to give us the height in inches. And so the new variable that we create is going to be height inches. And then we just ask for the first result. And so, so it gets created here. Now, when you do this with mutate, it's what it will do is the new variable that gets created gets tacked on at the end. Okay, so in this case, we had 13 original variables, and then this new variable, height in inches, is going to be the 14th variable and gets there. So if you want to, kind of just see what that looks like, you can then take the result. So keep in mind, this part is basically this result here where we've got 14 columns, and from there, we're going to select these 3 columns: name, height in inches. Okay, so we get Luke Skywalker in centimeters has a height of 172. In inches, that's 67.7. Okay, about 5'8". 5'7". Okay, so that's mutate. One thing that you got to keep in mind is that mutate will add a variable to the data set, right? It adds a column, which means it needs a value or an entry for every single row in the data set. Okay, so if you have 87 rows in the data set, whatever you're going to tack on needs to have 87 values, because every row needs to have a value. Even if the value is missing, okay, you just have to specify some kind of vector of the same length as the number of rows. Okay, and so cumulative mean will work, whereas if I just use mean, that will not work, right? Mean if I have 87 values and I say, what's the mean of these 87 values, I only get one value, okay? So that's not going to work. So here, cumulative mean, we'll take this and put it in here. And so this is what cumulative mean is Luke Skywalker is the first, so he has a mass of 77, so the mean so far is 77. C-3PO shows up next with a mass of 75, and so the mean so far of 77 and 75 is 76. And then R2-D2 shows up with a mass of 32, and the mean of 77, 75, and 32 is 61.333. Okay, and that's what we get here. And Darth Vader shows up with a mass of 136, and so he brings up the average mass up to 80, and so on and so forth. So that's cumulative mean. Okay. There's a bunch of other functions that are useful to use with mutate. Okay. There's pmin and pmax, which is element-wise minimum and maximum, which is different from the cumulative min and cumulative max. Okay, these are both what we call window functions, in that, you know, however many values you go in, when you throw it into pmin or pmax or cumulative min or cumulative max, you're going to get the same number of values out. Okay, cumulative sum and cumulative product and cumulative mean, I think those are all self-explanatory. The cumulative sum, product, or mean. Between will give you true false values. You kind of give it a range and it will answer, is this value within a certain range? Lead and lag will copy the values with some kind of offset. Okay, and then entile will bin the vector of values into n different buckets. So entile 2 will kind of give you values below the median and values above the median. Values below the median will get put in the first entile. Entile 1 will get, the value will be 1, and then entile 2, everything above the median will get a value of 2. If you do entile 4, it will divide it into quarters, right? So the first quartile will get the value 1, second quartile, so that's 25th to 50th percentile, will get value 2, 50th to 75th percentile will get value 3, and those in the largest quartile will get value 4. And you can specify any number, entile 10, and that will give it kind of into, I guess we call those deciles. Or you could do entile 100, and that will divide it into percentiles and things like that, right? All right, so here's an example of a bunch of these things that we can use with mutate. Okay, so from the data frame, or the original Star Wars Tibble, I've selected the columns name, mass, and birth year. Okay, and so those first 3 columns show up right here. Okay, and then after I apply mutate, inside mutate, I'm defining 4 new variables: cumulative min mass, ratio, mass year min, and lag 2. And so those 4 new variables show up after the original 3. Okay, and if I didn't do the select, then, you know, all 13 variables would show up, and then we would add four variables, and we'd have a total of 17 variables, and it just wouldn't fit on the screen here. Okay, so cumulative min, I think that operates the way we expect. Cumulative min mass, we get 77 because we have 77. Then the next value that shows up is 75. So the minimum value I've seen so far is 75. Then R2-D2 shows up with a mass of 32, so he shows up down here with 32. And then Darth Vader shows up next, but the smallest value we've seen so far is still 32. Okay, and that continues on. Here I've got ratio. Ratio is going to be the mass of our person divided by, and then notice what I'm doing here. I'm dividing by the mean mass with missing values removed. Okay, so I've got so the mean of the mass, this is one constant value, right? So it's basically, I'm taking this column of mass and I'm calculating a mean, and that's going to be one value, and I'm going to do everybody's mass divided by that one mean value, which is unknown, but or which is some number, and so 77 divided by that number gives me 0.791. Okay, so just under 100 is the thing there, right? Okay, The mass year min, this uses the pmin function, okay? So cumulative min is this. Pmin, you give it basically a couple vectors, and it does element-wise minimums, okay? So in this case, I'm giving it the column mass and birth year. And it's saying, okay, this doesn't have any semantic meaning. This is not like a meaningful variable. I'm just using it to demonstrate what pmin does, okay? So it says Luke Skywalker's mass is 77 kilos, but it was 19. Birth year is 19 years, okay, before the Battle of Yavin. And so which number is smaller, 77 or 19? We're going with 19 here, okay? Whereas C-3PO, his mass is 75 and his birth year is 112. Which number is smaller, 75 or 112? And it's 75, okay? So it's doing element-wise minimum comparisons, and that's what pmin does, right? So, yeah, I just wanted to have a demonstration of the difference between pmin and cumulative min, okay? Lag here basically just copies this column. Here, I'm taking the mass year min column that I just created, and lag will basically copy that thing with an offset, okay? So if I say lag 2, it's going to offset it by 2, okay? So this column, 1975, 32, the first two gets NAs, but then 1975, 32 show up, with an offset of 2. So if you have like time-related data, this can be a useful thing to try, right? So if you have like maybe you have like monthly information and you want to compare, this month's value to the same month last year, right? So you want to compare January 2020 to January 2019. So you can take your thing of data and then you can do lag 12, and it will offset it by 12 months, okay? And you can compare kind of this year versus last year and things like that. And then you can further apply mutate and do like a difference. You can do subtract, current versus, the lag 12 value, okay? And then calculate kind of a difference between this year and last year, right? So all of these things you can do, right? One thing to note is that when I do this mutate thing, I created a variable called mass year min, and I'm immediately using mass year min, this new variable I just created, in the definition of another variable, okay? And dplyr and mutate allows you to do that. It allows you to use a variable that you've just defined kind of immediately without, in base R, if you want to create a new variable, you kind of have to, you create it and you store it using the $sign somewhere. And then once you do that, then you can create another variable that uses it. But mutate allows you to kind of create this variable and you immediately use it right afterwards, which is really nice and convenient, okay? So that's mutate. Is that good? Okay, and then lastly, well, not lastly, we have arrange, okay? So arrange lets you kind of sort the resulting data, right? So you take, so here we've taken Star Wars, we're just gonna select these columns, and again, you can kind of chain all of these things together, but this time I'm going to arrange them and arrange the rows, in this case in descending order by birth year, right? So if you want them in descending order, you wrap that variable name with the function descending, and then after, if there's a tie, you can break it with the variable mass, and you can specify several of these things. You can also put in a variable with string information, character variable. And it will use alphabetical order, okay, or whatever language locale you have set. All right. So in this case, when we do this, we see Yoda is the oldest character at 896 years old at the Battle of Yavin. I think they get that because Empire Strikes Back takes place 4 years after the first movie, and Yoda says he's 900 years old, so I guess we say he's literally 900 years old. So that's what happens. Okay. Here we have Ki Adimundi and Qui-Gon Jinn, both at 92 in their birth year, and so their tie is broken using mass of 82 and then 89. So the mass is in ascending order. Okay. So that's a range to sort your rows. All right. Okay. This is where we really get into the power of dplyr. And so the summarize function in dplyr is very powerful, very useful. You can use this, and just if you can use dplyr well, like, you can win DataFest. Okay. I'm not even kidding about that. So, and so basically, if we think about what a summary function does, is it takes a whole bunch of values and it reduces it down to one value, right? And this is incredibly useful because our brain is much better thinking, has a much better, easier time thinking about one value, comparing one value with another, versus comparing a set of like 10 or 20 numbers together, right? So if you wanted to kind of ask, like, are you doing better in this class or this other class? Okay, you're not thinking about the individual assignments and exams and things like that, right? Because you might have like 5 homework assignments and 2 exams so far, and this other one you got a few other things, and you're not quite thinking about how all of these individual assignments, and say, well, I did well on homework 1, but not so good on homework 2, and not so great on homework 3, but I did well on homework 4, and things like that. And then you're thinking about it, it's weird. And so basically, to help you compare, are you doing better in this class or this class? You just say, well, my overall grade in this class is a 92, and my overall grade in this class is an 87, and there, 92 is higher than 87, and blah 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 blah. Okay, and that's why people, like, when you apply to college or grad school, they just summarize your academic life with your GPA, right? Like, it's very reductive, and it's not a good, I don't know if it's a good system, but it's a lot easier to compare one number at a time, okay? And so summary functions are useful in that way. And so here we're taking this, and I've just selected the height variable and mass, but then I'm creating all of these kind of summary values, all right? And the way we create the summary values is we use the function summarize, and we give it the variable name or the value name that we're going to create. And here it's called average underscore height, and we give it the formula for calculating it. In this case, it's going to be mean of the height variable, remove the missing values. Here I've got variance height, and this is calculated by doing variance of the height, remove the missing values, average mass, mean of the mass, remove the missing values. And we got min of height, max mass, count doesn't need to specify a variable, you can, and you get n there, okay? And then we get these values, 174, 1209, 97.3, 66, 1358, and 87. And you might say, well, that was a lot of work. I could have just done, mean Star Wars $height, okay? And then I would have gotten the same value right here, 174, all right? And that's true, okay? But the power of summarize comes in when we pair it up with the function grouped by. But anyway, this is what we have, right? So you define kind of the thing. The name that you give it is arbitrary. Here I called average underscore height because that was a name that made sense to me. But if you wanted to call it mu, or just whatever it is, whatever name you want, that's fine. Okay, so as long as you're kind of following R's naming rules, you can specify whatever name you want. Okay, it doesn't have to follow any kind of system here. Okay. All right. So here's this function group by. Group by is incredibly powerful, and when you use it all by itself, it doesn't seem like it does much, okay? It's when you combine group by with one of the other verbs that you get some power, okay? So here, I'm selecting the name, the height, the mass, and the species, and we're going to group by species. And when you do this, it just looks like I've selected those 4 columns, okay? But the important note here is that groups, there's a list here. It says species, and there's 38 groups that exist in my data set. That's 87 by 4, okay? 87 by 4, we're going to find the, we've got 38 groups defined here. So what I'm going to do is I'm going to combine group by with summarize. Okay. So I said from Star Wars, group by the species, and then we say summarize, and we say find the mean height, standard deviation of height, mean mass, standard deviation of mass, and the count. Okay. And so this is what we get. We get mean height, standard deviation height, mean mass, standard deviation mass, and the count. All right. And then it goes and it calculates. This is pretty much like a t-apply. Okay, it's very much like a t-apply in that it has applied these functions and calculated these summary values for each of these different groups. Okay, and so we've got the Alina species has a mean height of 79 and a mean mass of 15. Okay, there's no standard deviation when you have only one value, right? So if you only have one value, well, I guess depending on who you ask, right? The standard deviation is either undefined because you're dividing by n minus 1, or it's 0 if you divide by n, right? So, so here if we're dividing by n minus 1, we get an undefined standard deviation for all of these things, okay? But we have 5 droids in the database, okay? And the mean of those 5 droids is 140 with a standard deviation of 52. And a mean mass of 69.8 and standard deviation of 51, okay? And so, again, the result here is a tibble, a 38 by 6 tibble. So I can take this and take that 38 by 6 thing and treat it as another tibble or thing and put it into another function. And so I'm going to take this and the exact same thing. So right here, we're at 38 by 6, and then I'm going to filter it just so that this count column is bigger than 1, okay? And when we do that, now I get 6 rows. We get humans with 35 people, and 5 droids, 5 without species listed, 3 Gungans, 2 Kaminoans, and 2 Mirialans, I don't know, okay? And then I've had them arranged in descending order by count. Oh, and I've asked only to limit us to the top 6 using head. Okay, so so this is the result. We've applied group by and we've applied summarize, and then you can filter and arrange and combine all of the different dplyr verbs here. Okay. When you learn dplyr, okay, and you're learning R or any kind of foreign language, there's a few parts to it, right? You've got to learn the grammar, how the things go together, and then the other part is learning the grammar, learning the vocabulary, okay? And vocabulary is harder, otherwise, you won't be expressing things efficiently, right? So, if you're like in a foreign country and you're not super great with the language, you might not know that you call this the dishwasher, right? The dishwasher, and you might have to say, well, do you have a box where I put in dirty plates? Or you can say, my box with the dirt, where I put in the dirty plates is broken, and that's why, my life is hard or something. But when you learn the vocabulary, you can be better, right? And so this is going to be an important thing, is learning the vocabulary of all of these different verbs and using them effectively. Here I have combined group by with the function mutate. Okay, group by with mutate. So notice what happens here. I'm calculating mutate, but I'm going to calculate a new column called the z-score for height. Okay, z-score z-score is basically, x minus the mean divided by the standard deviation. And so I'm doing height minus the mean divided by the standard deviation, okay, ignoring the missing values. And what I've done is, because I've grouped by species, and we have, and first I filtered and it just said, only look at humans and droids, okay? Humans and droids, or, species is missing. We're going to select name, species, height. We're going to group by the species, okay? And what we're doing is we're going to calculate the z-scores for all of these things, okay? And what we're doing is, because of the group by, we're going to calculate Luke Skywalker's z-score for height based on other human heights. So we're going to say, we're going to take his height, and his height is 172, but he gets a negative z-score because he is shorter than the other humans in the data set, right? So the average human height in this data set is higher than 172, so he gets a negative z-score. Whereas C-3PO, who is shorter with a height of 167, he gets a positive z-score because he's being compared to the other droids, okay? And so this is a nice, this is a really powerful feature that maybe seems to be lost on you guys because no one's impressed, but that we are calculating, values like the z-score that depend on summary values that are associated with the groups, okay? So, we're calculating the z-score by comparing it to the mean human height and the standard deviation of the human height, or the mean droid height and the standard deviation of the droid height. If you get rid of this, I'm copying the exact same code here, but I just commented out the group by line, okay? If I comment out the group by line, then we can see that Luke Skywalker is taller than average, just barely taller than average, and C-3PO is a little bit shorter than average for everybody that's been selected in this data set. Okay, and so group by is really powerful. Okay, one thing to note, just kind of stylistically, with these verbs, the verbs often get its own line. You don't have to do it this way. You can write all the verbs and put all the pipes, but it's often one style recommendation is when you use a pipe, you go to the next line and put a verb separately. So each of these things, like when I write it out this way, we take the data set, we pipe it into select, and then the next verb, group by, gets its own line, summarize gets its own line, filter gets its own line, arrange and head get their own line. And then within summarize, because I'm adding new columns here, each of those new columns that I'm adding gets its own line. And this just kind of breaks up the all of the commands, because this is really just one very long command, right? It's one very long command, and in order to kind of structure and organize it in a way that's readable, this is often kind of the recommended method, but you're not required to, okay? You can apply group bys with a hierarchical group by, okay? And so for this, we're gonna look at just some toy fake data, all right, where we've listed off countries, okay, and I guess cases of some mysterious disease. So we have Afghanistan in the year 1999. For the females, there was one case. In Afghanistan in the year 1999, for males, there was one case. Afghanistan in the year 2000, females, there was one case. Afghanistan 2000, males, there was one case, okay? And then we do the same thing with Brazil and China. And then just to keep everything simple, we gave everybody a 1 here, and everybody here a 2, and everybody here a 3, okay? And, 99, and so on and so forth. So when I do this the first time, I'm going to group by country and then year, okay? And then I'm going to summarize by summing the number of cases, okay? And so for Afghanistan, when I sum them, I get 2 in 99 and Afghanistan 2 in the year 2000. We basically combined the 1 male and 1 female, 1 male and female, okay? And then when we look at Brazil, we're going to combine the male and the female, or sum these two, and we get the 4. And then for China, we get 6, okay? And so I grouped by country and then year, and then this thing, So I've taken this result and I've stored it into summary 1. Okay, and then I'm going to take summary 1 and apply summarize. Okay, so I could have done it in one line by just piping this thing into the next, but I'm just showing you kind of saving the results. Summary 1 gets piped into summarize, and basically it is going to apply a summary function here. And because we've got a hierarchical grouping, we group by country and then year, if I apply summarize again there, it's going to group by country only. Okay, and we get Afghanistan 4, Brazil 8, China 12. Okay, and then if I apply summarize again here, doing the same thing where we apply sum to the cases, then it just gives me the sum of all of this and it gives me 24. Does that make sense, how this is working? Okay, so that's when I grouped by country and then by year. If I do the exact same thing, but I just switch this, group by year and then country, okay, this part looks almost the same, okay? But we can see the hierarchy is year first and then country, okay? So we get 99, and then we got Afghanistan, 99, Brazil, 99, China, and then 2000, Afghanistan, Brazil, China, and so on and so forth. And then we go 246, 246. And then if I apply summarize to this, how many rows will I have? So if I apply summarize to this table of 6 rows, I will have two rows, right? I will have a row for 99 and a row for 2000, okay? Because here the hierarchy is group by year and then by country, okay? And that's what we've got here. And then if I apply summarize here, because there's no groups, then it just gives us 24 total, okay? And so this is a really powerful thing that you can do with dplyr, is that you can create these hierarchical groups, and then, you know, it will summarize and group accordingly as well, okay? All right, we will end there. I'm working on writing up homework 3. You can expect that to probably get posted sometime tonight. And we'll see you guys on Wednesday to begin our discussion of regular expressions.